Hello everybody, and welcome to this short instructional video on assignment 7, which is here for you to practice recursion. This assignment will be different than what you're used to because there are no classes, alright? There's only 5 functions. And the functions are not really related to each other. Now, the first 3 pages I include some documentation on recursion. So if you're still a little shaky on recursion, I highly recommend that you read this. All right, I give you some nice example here with the Fibonacci function. And I include a whole bunch of details about it, including a nice pretty picture here. Now, for each function that you code, I will ask you 4 questions. This assignment is a little bit different in that you're going to have to answer 4 questions about each function that you write. And you're going to submit this as part of your homework in a PDF. All right, I'm always going to ask you, what are your base cases? And there might just be one, that's fine. What are your reduction operations? Once again, there might just be one, that's fine. I ask you to draw the tree diagram. That is, what will this function look like when you call it with these parameters? And then I also ask you, what kind of tree does your function make? All right. Now, if you don't know how to answer any of those, of course, you're welcome to ask questions, but please read this first, all right? Because I answer all 4 of those questions with the Fibonacci function. You'll notice that I answer what the base cases are. I answer what the reduction operations are. I talk about drawing the tree, and then I also talk about what type the tree is. Excuse me. All right, so please do read this. It'll be helpful to you, I promise. Now, let's go ahead and get into the program flow. There's really no flow other than that you're going to code 5 functions. They're going to be each tested individually. Now, you have to submit this to CodeGrade, and I'm just going to remind you, I'm not sure if your instructors told you because they were trying to be sneaky, but proven by the Church-Turing thesis, anything that can be solved recursively can also be solved with loops, with iteration. In fact, I would say 4 of these functions will be very doable for you without recursion. That is, you might write the solution to them with just a loop. Now, I don't want you to do that, and CodeGrade is going to explicitly check your function to make sure that it is recursive, all right? So, when you submit to CodeGrade, you have to look out for that stuff. On every test, there is a check. All right, there is a check. And we'll say, hey, is your function recursive? And we'll look in your body of code, and if it can't find it, you need to code it recursively. Notice I say, student, this is not recursive. You get 0 points. Once you've made your function recursive, you will then pass this test, and we will check your output, all right? So it has to be recursive. Now, the script that I wrote to check your code is very basic, and it gets really mucked up if you have block comments in your code. So for this assignment, and hopefully just this assignment only, you're not allowed to have block comments at all, all right? If you come into your skeleton code and you, hold on one second, and you put a block comment anywhere, CodeGrade will not pass, all right? Let me just show you that. If you put anything like that, even if you put this like out here or something, behind a comment, if CodeGrade sees this, you will not pass, all right? So take it out. You are not allowed to use them for this assignment. Please just use regular line comments. All right. So now that's out of the way. Let's talk about this part here. For each function that I ask you to solve, I included the number of lines that I solved it in with my solution. Now, this is not a competition. I'm not trying to make you feel stupid or anything like that. I am just putting it here to remind you not to overthink about these problems, okay? So if you are really digging into some of these functions and you're writing a recursive solution and it's getting too complicated and you just keep adding code and code and code, lines of code, go ahead, stop, take a breather, look at the number of lines you have. And I would say if it's about twice this, If it's over twice the amount that I used, you're probably overthinking it. And what you should do is you should stop and reapproach the problem. Okay? You should stop and reapproach the problem. So once again, this is not here to discourage you. In fact, I kind of hope this excites you. 4 lines of code. You can do that, I'm sure, right? So this is here just to encourage you to not overthink the problem. So just keep that in mind. I'm also going to make note that I code kind of acorn style. So, you know, 1/3 to half of these lines are just brackets, all right? In this function, maybe only 3 lines are actually doing something. So I hope that you can get excited about that. Now let's go ahead and look at our first function. This is integer exponentiation. The first parameter is the number, and the second parameter is the power, the exponent. All right. This function will be called like, let's just look at the individual tests. This function is called like this. All right, 2 to the third, to the second, to the first, to the 0, 10 to the fourth, or 3 to the third, 7 to the fourth. All right. That's how this function is called. And that's it. This one should be very straightforward, all right? I expect you to be able to do this one very easily. Next, we come on down to counting specific characters. I'm going to ask you to count the number of times a character appears in a string. Let's go ahead and look at this string here. Hello, and welcome to my guide. If I am going to count the number of m's in this string, I will call the function like this, all right? Now, this takes 6 parameters, a whole 6. That's a lot, but they're necessary. The first thing that's passed is the string, obviously. You need that. The second thing that's passed is the character you're looking for. You need that. The third thing that's passed here is the current index that you're looking at in the string. So if I pass 0, I'm going to start at H. If I pass 5, I'm going to start at the space. If I pass 20, I start somewhere over here. If I pass 29, I start at the exclamation point, all right? So that's the thing about this function. It can start from anywhere, and it will still succeed in counting the number of characters or the number of times this character appears in this string. So you'll notice that the output should be 2222. Obviously, we passed the string length. That is, don't go out of bounds. I don't want you to go out of bounds. And then we pass in these 2 booleans. The first bool is the left bool. It says, if this is true, I want you to continue to search in the left direction. And the right bool here on the right side, if this is true, that means I want you to continue to search in the right direction. So when this function is called, you'll notice I say, hey, go ahead and search left and search right. And then in your recursive calls, you will adjust these. And you will say, hey, you don't need to check over here on the right, but go check on the left. All right? So that's really how this function works. All right, you can check that out in test 2 here. Where is that? Here it is. I run a for loop here, all right? I'm going to test all of these characters. So once you get these down, you should be good to go, at least for the simple ones. And now we're going to get into the fun ones. I would say you can take these in any order you'd like. If you want to do the balloon one, the sentence one, or the alpha merge. If you want to do any of those, feel free to take them on at this point, because those first 2 were just to get you warmed up. This one, I will say, if you can solve it with a loop, I commend you. To this day, I'm not saying I've spent a whole lot of time on it, but I definitely have not come up with a solution for this that is not recursive. This, in fact, is a problem that kind of by design is solved easily via recursion, but when it comes to the actual solving it with a loop, oh, it makes your brain hurt. All right? So this is why recursion is helpful. This is a perfect example, in fact, of why recursion is so useful to computer scientists. Now, notice the number of lines, only 10, all right? And it's going to do a whole lot. I'm sure you're going to be surprised here. So it takes 6 parameters. You've got your double pointer grid. That's a 2-dimensional grid, right? Here it is. You can see it down here. It takes the current height and the current width. That is, what coordinate am I currently looking at in the grid? So if I'm looking at 1, 0, I'm looking here. If I'm looking at 3, 5, I'm looking here. Then we pass in the height and the width. That is, those are the bounds of the grid. Those are to keep you from going out of bounds. And then finally, we have the car balloon. That is, what is the color of the balloon that we're looking for? So given this grid, if I call pop balloons, let's say at 3, 3, we'll check the height first here, and then we'll go to the third column, and we're at that B. I'm going to pop that balloon. In turn, I'm going to pop all of the adjacent blue balloons. That is, I'm going to pop this one and this one. Now it sets off the chain reaction because this blue balloon is going to pop that one, and that one will pop this one, and that one will pop this one. And then this one is also going up the other side. That is, this one had popped, so now this one will pop, this one will pop, and this one will pop, and those should meet right around one of these two. All right, and look, we end up with a new grid where all the blue balloons have been popped. Now, the thing to keep in mind is that this only works up, left, right, and down. All right, that's a hint, by the way. Think hard about that. When I say up, left, right, and down, all right? Really think about that. This is like the core. This is the core of the recursion for this problem. Up, right, left, and down. This function does not consider diagonals, all right? So let's look at a similar example. If I'm going to pop the balloon at 2, 4, I'll go down to 2. I'll head to 4. Here I am. If I pop that yellow balloon, I will pop the 2 other balloons that were touching it, but this diagonal one remains untouched, all right? So we do not consider diagonals. Of course, the equivalent to popping a balloon is overwriting it with a blank space. This is also the key to stopping the recursion, all right? You will need to overwrite the characters in the grid. So I really hope you have fun with that one. Let's look at this one, counting the non-space characters in a sentence. Notice I only did 7. That's pretty small. This function takes a double pointer. That's a 2-dimensional character pointer. And it takes an unsigned int here, which is the current word you're looking at, and an unsigned int, which is the current letter you're looking at, current character. So here's an example of hello and welcome to my guide. Notice here that these pointers are stored in the array. These are the words. So we have 6 words in this array, and it's going to be terminated with a null pointer. That is, that null pointer is there to let you know when you're done. All right, and each of these addresses are going to be pointing to a character array of different length. And each of them are terminated with a null character. This here is a null character. That was my mistake. So each word is terminated with a null character. And that null character is there to tell you that you're done with that word and you need to move to the next one. It will always be called like this. All right, it'll always be called like that, starting at 0, 0. That is, you don't have to worry about starting anywhere. All right, it'll always be started at 0, 0. And then finally, alpha merge 28. All right, that's a little scary. All right, but let's cut that down. Maybe only 14 to 17 of those lines are actually doing work. In addition to that, this function will be doing some dynamic memory allocation, your favorite. So that's probably why the line count is so high. All right, so don't let that discourage you. But keep in mind, if you get up to 56 lines in this function, maybe take a step back, okay? So here we've got 6 parameters, a whole 6. What this one will do is it will store a brand new, it'll make a brand new character array. So provided, say these 2 character arrays that are already in alphabetical order, it will merge them together. It will also preserve the alphabetical order. So notice we've got A, C, E, G, I, and B, D, F, H, J. It's going to merge them into this big one down here. And notice that that alphabetical order is preserved. So it's going to kind of look at this A and this B, and it's going to say the A needs to go first. And then it will look at the B, and it will look at the C, and it will say, hey, the B needs to go next. Then it will look at the C, and it will look at the D, and it will say, hey, the C needs to go next. So on and so forth. All right, so the first parameter is the destination array. All right, notice that it's null pointer here, but by the time it comes out of the array, it's a whole new thing. All right, it's a whole new thing. In fact, I'm going to edit this. You should not be able to print it like this. It should be a for loop. But just imagine that it's going to print that. All right. Then this here is the current size of that array. That is, when it goes in here, it's size 0, right? Size 0. These here are the arrays that you're going to merge. And then these here are the current indexes for each of them respectively. So this one is the index for this array, and this one is the index for this array. So you need to make a whole new array, store it in this pointer, and then in addition to that, this function needs to return the size of that new array. Okay, that'll be 10. Go ahead and compile your code CS135 style and run it. In this assignment, I will provide you all of these test files. In addition, I'm going to provide you main, which is just all of them together. All right, and I will just point out in the very last one, alpha merge, I am using a for loop to print it. All right, so that was a little bit my mistake there, but I am using a for loop. And this code that I've written in the PDF will not work. That is, don't pay attention to that. I will be editing that anyway. And then finally, the comprehension questions. All right, you've got to document all of the stuff that you answered in a PDF. You should have 20 answers. All right, that's 4 for each recursive function. And you are going to submit this to Web Campus in a PDF or a Microsoft Word document. And that's that. All right. So I'll give you some example runs. All right. We'll run with Valgrind just to make sure that I did fine. No problems here. So you notice that main will run all of the tests in order. Pop balloons there, some more pop balloons, count letters, and alpha merge. If you want to run them individually, just select the appropriate test, perhaps test 1, compile it, run it with Valgrind, and you'll just do the individual test there for integer pal. All right? So you can do that. Like I said, I'm doing Valgrind checks, so make sure that you stay in bounds and you don't do anything fishy. And that's that. I will mention that I am in your Discord, all right? So you guys haven't talked to me before. That is the students in the other sections. But I am in that Discord, so I do trust that your instructors will be able to help you with this, and your TAs as well. But if you ever need any clarity from me, I am in that Discord, and you can see me there. Perhaps maybe I can pull that up now, just so you know who I am. So let's see here. All right, so let me pull this over here. And that's me right here, all right? I'm James Petrowski, and I exist here, all right? So if you need me, I'm here. Thank you for watching this video. Best of luck on your assignment. I will see you guys next time.